Welcome back to the lecture series in bioelectrochemistry. So, in the last class, I gave you a taste of what all the power a electrochemical cell can offer you. So, looking at the voltage and the concentration of the reactants on the different half cells, if there is one component which is unknown, you can figure that out. And in the last class, we talked about how we were analyzing H plus ion concentration. So, one thing what I wish to highlight now is how it differs when we translate these systems in biological systems. What does that mean? So, that essentially means that most of the biological systems are nothing but redox chemistry. There is electron transfer happening all over the place. The whole biology, whether starting from photosynthesis to respiration, whatever you talk about, these are nothing but transfer of electrons. Of course, not at the inorganic level, huge amount of electrons are getting transferred, but end of the day it is oxidation and reduction which is happening, which is the fuel or the machinery which is driving the whole energetics. Okay. So, could we directly translate the value of E0, what we have as of now derived electrode reduction potential, standard reduction potential to the biological systems? Actually, that is not possible. Why that is not possible? We will discuss it today very briefly, and from there we will move on to different forms of electrodes, and that was the reason why I kind of delayed this far, almost took 4 or 5 additional classes as of now to come to this point, because there are certain aspects which we needed to understand. So, let us start the class, which is our week 3, lecture 2, and this is overall, this is lecture 12, and lecture 12 we will be talking about biochemists use of E0, and now I am adding one more term to that, E0 prime, which is different from E0. Okay. In respiration, molecules from food are oxidized by oxygen. So, this is a common thing, you know, these are getting oxidized. This is what happened in respiration to yield energy or metabolic intermediate. The standard reduction potential that we have been using so far applies to systems in which all activities of the reactants and product are unity. Whenever we calculate E0, we assume reactant and product activities are unity. This is our assumption, and if H plus is involved in the reaction, E0 applies when H plus is involved in the reaction, E0 applies when pH is equal to 0, or in other word A H plus equals to 1. So, whenever H plus appears in a redox reaction, or whenever reactant or product are acid or bases, reduction potentials are pH dependent. So, this is one catch which I wanted to bring to your notice. In the last example, if you see, when we talked about the H plus concentration, so to realize that standard reduction potential calculation are based on the fact that pH is 0 and all the activities are unity, which is perfectly fine as long as we are dealing with such system. But think of a situation, think of the last class when we talked about a situation like this, where one of the key contestant is this. Now, as soon as you have H plus ions coming into the play, the game changes, because it shifts the pH, and as soon as it shifts the pH, then the dissociation, association, all the activities, everything go for a toss. Having said this, let us realize another fact, that biological system does not work at pH 0, except probably in your stomach or in the gut, where you are digesting the food, which is extremely acidic pH, but the whole biology works at pH 7. So, now our basic premise of using E 0 was at pH 0, which is perfectly fine and where everything was unity, but we cannot directly transfer it in the biological systems, because we are dealing with pH 7 situation. Okay. So, that is where we will be now proceeding further. So, because the pH inside a plant or animal cells. So, for example, one second, inside a plant or animal cell, the pH is 7. So, the reduction potential that apply at pH 0 are not appropriate. For example, at pH 0, say for example, we take an example at pH 0, the ascorbic acid or vitamin C is a reducing strength, is a powerful reducing agent than succinic acid. However, at pH 7, this order is reverse. It is the reducing strength at pH 7, not pH 0, that is relevant to a living cell. Okay. And always remember, whenever H plus, so this I want you to realize, whenever H plus appears in a redox reaction, or whenever reactant and products are acid or bases, whenever reactants and products are acids and bases, the reduction potential are pH dependent. So, keep this aspect very clear in your mind. Okay. So, it is the reducing strength at pH 7, not at pH 0, that is relevant to living cell. This is our critical point to remember. And always realize that we have all such situation where you have acid bases which are involved in the biological modules. Okay. So, now what is the way to get around it? The standard potential for a redox reaction is defined for a galvanic cell in which all activities are unity. Okay. Now, the formal potential, this part is very important, that what we are going to talk about, which is represented by E 0 prime, sorry, it is essentially E 0 prime like this. So, is the reduction potential that applies under a specified set of conditions. This is our, which is used by the biochemist, formal potential. So, this is, we are getting into the domain of bioelectrochemistry. bio-electrochemistry now, okay, is a reduction potential that applies under a specific set of conditions, which includes pH, ionic strength, concentration of complexing agent, concentration of complexing agent. At this point, you people have to remember these three aspects. Okay. Biochemists call the formal potential at pH 7 as E0 prime. Okay. This is that E0 prime. Now, I will put some of the values for you to realize how E0 prime looks like. Say for example, let us draw a small table of some of these values. Okay. So, the reaction out here E0 V, which is standard potential, and here you have E0 prime in volt. Okay. Now, let us take the first reaction, oxygen plus 4H plus 4 electron, and the famous situation 2H2O. And if you get the E0 value of this, which is plus 1.229, whereas E0 prime in the biological module it is plus 0.815. So, this is where the water splitting happens. Okay. So, this is basically you are splitting the water. Okay. Now, take a simple one, iron 3 plus electron, it is getting reduced to make it Fe2 plus. Okay. Now, in that situation value is 0.771 as well as 0.771. Now, you realize the difference, both are same. Why both are same? Because the previous case, this was the reason why I want to show you, you have H plus ions which are involved in it. So, if you, I will give you a few examples which will tell you the story. Whenever you have the pH involvement is there, the storyline is going to change out here. And when pH is not involved there, it will remain the same. So, please appreciate these two interesting situation. Okay. Now, let us get to another one, another example in that line. Okay. Okay. So, say for example, let us take the case of iodine, I2 plus 2 electron, making it 2I minus. Okay. And the changes are E0 changes 0.535 positive 0.535. Now, you realize it is similar to the ferrous ferric ferric ferrous. Now, I come to another situation where you have the biological molecule like cytochrome. Cytochrome A, which is Fe3 plus electron, it becomes cytochrome A Fe2 plus, which is getting reduced, and the values are plus 0.290 plus 290, because again there is no involvement of any hydrogen ion or any kind of acid base situation. Okay. So, now I will move on to another example, which is a very tricky one, which is oxygen gas plus 2 protons plus 2 electron, making it H2O2, and in that situation your value is plus 695, whereas if you measure it with E0 prime, the value will be 0.281. Now, here is another example of the difference you could see. Similarly, you can do it for cytochrome CFe3 plus electron to make it cytochrome CFe2 plus, you will see a plus 254 volt E0 prime. Okay. Similarly, let us take another example where say pyruvate to lactate. Okay. Once again, pyruvate plus 2H plus 2 electron, this is making it a lactate. Okay. Now, if you look at this reaction, pyruvate to lactate under standard reduction potential, it is plus 224, whereas if you use the E0 prime value, it will be 0. minus. Now, look at this one, the difference. So, what I mean, I will give you the list of all these things. What is important for you to realize is, for us, for bioelectrochemists, it is important that we understand the concept of E0 prime or the formal potential, because this is the potential which we will be using in most of the electrodes time and again and time and again. Okay. So, keep that formal potential in mind, and let me highlight another aspect here. So, one way to measure E0 prime is to establish the half cell, which is a formal concentration of oxidized and reduced species are equal and the pH is adjusted to 0. So, keep this in mind. One way to measure E0 prime is to establish a half cell in which the formal concentration of the oxidized and reduced species are equal and the pH is adjusted to 7. So, keep that in mind, and there is another aspect which I have not dealt as of now and I will be dealing with later, is the concentration of the complexing agent. This part is very critical, the concentration of the complexing agent. We will come later with the monoprotic system, diprotic system. I am not introducing all those at this point purposefully, but what I want is you people understand that whenever we talk about the formal potential for the use in the biochemical reactions, we have to always keep in mind H plus ion concentration, ionic strength it cannot be unity, and the concentration of the complexing agent will come later as we will move on to the different kind of electrodes. So, with this we kind of have covered most of the fundamental basics, what you will be needing to understand the electrodes. Of course, there is much more to it as we will do it, and wherever the opportunities will come I will highlight it, but it is much of a doing things, once you do these kind of things you realize, and much of a kind of to think through it what is happening in this whole process. Okay, I will close in here, and we will continue with the different kind of electrodes in the next section. Thank you.